Hi everyone, welcome to my channel. This video is part of a playlist on AKS, Azure Kubernetes Service Networking. What you see on my screen is a layered architecture diagram created using Draw.io, and I have created detailed videos on how to create this. If you are interested in learning more, be sure to check out the other playlist on Draw.io. Again, all the Draw.io files, the scripts, and the content presented today is in my GitHub repo, the link below. Today's topic is about CNI overlay network plugin. And in the upcoming session, I'll cover the dual stack IPv4 and IPv6 plugin with Kubnet. So today we'll start with a quick recap of Kubnet and Azure CNI and the differences with Azure CNI overlay, understand the key design points, and then we'll jump on to VS Code and build the cluster from scratch. While the cluster is building, we'll talk about core concepts, inbound, outbound flows, and then we'll run validations from the command line and the portal. And then we'll finally close out with some troubleshooting tips. So let's have some fun. If you are following along with me, our starting point is typically a brownfield environment. So let me kind of put the Draw.io to the starting point. So this is what is a brownfield environment. In other words, we start with a classic hub and spoke architecture. We have hub and spoke, and we have the branch connected via site-to-site VPN. Okay, so this is the existing environment, and we are going to deploy the AKS cluster in this existing environment. And so let's do a quick recap of the CNIs that we have already done. So this is the Kubnet CNI. If you remember the in the Kubnet CNI, and the way to look at this is I will have the CNI noted down in the top right-hand corner, and this is the part of the playlist or the series on AKS networking. Okay, so let's do a quick recap again. In case of the Kubnet CNI, we noted that the pod network, the cluster network, and the node network were three distinct networks, and pod network was within the cluster in a completely separate space than the node network. Now let's go into the CNI, and again, there's a detailed video on this as well. So in this one, as you notice, the node network and the pod network are in the same subnet, and then the cluster network is separate. So now let's compare that with the CNI overlay. In case of CNI overlay, the node network, cluster network, and the pod network are different, and the pod network is also the overlay network. Okay, so those are that's just a quick recap of how they all look like in the same diagram. And so let's talk a little bit about what we're going to do in today. So we'll start with this green brownfield environment. We'll deploy the three nodes and the AKS nodes. And then we will also deploy these pods, and then we will look at when you deploy these pods, you will use a deployment.yaml file like we've done in the previous sessions. And once we have the deployment.yaml file, we will go ahead and look at the inbound and outbound flows from within the cluster. Okay, so with that knowledge, I want to do a quick comparison of the use case here. So the main use case for CNI overlay is that you can see that the pod network is separate from the node network, just like how it was in Kubnet. So the advantage is IP address conservation. So we get a lot of IPs for the pod network. And the important thing is that because this is an overlay network, we don't need UDRs to route traffic back to the cluster. So by that, what I mean is, if you remember, let's take a quick peek at the CNI overlay network. And if you remember, there was a scenario where we needed, let's look at the outputs and deep dives to find the exact screen capture. So in case of the Kubnet design, we needed this route table, right? So this is a route table that is required to route these specific pod networks to the proper nodes. So these are the node IPs, and you were routing the pod networks at the subnet level, right? So these UDRs were required in Kubnet to route the appropriate pod traffic. So compared to that, in case of the CNI overlay, so let's go back into the CNI. Because it's an overlay network, we don't need those UDRs to route the traffic to the pods. That's the biggest distinction. And of course, when you go in and out of the cluster, when the traffic leaves the cluster, it does get netted to the node IPs. So the net is still happening, but the biggest differentiator is the overlay network. So looks very similar to Kubnet in that regards. So with that, let me jump on to the VS Code, and we will deploy the cluster. All right. So this again, these scripts are all in my GitHub repo. So let's get started. So we'll start with the AZ account command. If you haven't excuse me, logged in, go ahead and log in. In my case, I'm already logged in. So you can see that my account shows up. Excuse me, I've created an alias for kubectl. So that tells me that I have an alias. And this is probably not needed anymore. I had this because some of these were in preview. So disregard those. And then let's start with kconfig get contexts. So if you remember, this is just a command to get all of the Kubernetes context. It allows you to connect to the AKS cluster. Let's remove this 99 because this was the one that I created before. And you can use this delete command to delete any context that you don't need. So we'll create a new one for this. And so now let's run the kconfig get context command again. And you can see that these were the previous two clusters that we created from the Kubnet session and the CNI session. So today we'll create the overlay cluster. So these are the variables. You can set your variables here. I already have mine defined. So let's drop these. Now let's go over each one of this so that you know what these are. Again, these two are existing VNet and subnet. I'll show you the existing one in the portal. And has to be a unique, this DNS has to be unique across the region. And this one is the cluster name. And in my case, if you look at it, the cluster name and the DNS name are the same, but they need to be, this DNS needs to be unique across the region. And the important thing to note is the plugin here is still Azure over here, the same as what we did in the CNI. And this VNet resource group is where the VNet exists, and this is the resource group where the cluster gets created. So let's go ahead and create the resource group first. And Now that the resource group is created, we'll create the container registry. And while the registry gets created, I want to show you in the portal the existing subnet and the VNet. So as you can see, I have a VNet that exists, and we've been using different subnets for the different network models. Before we used the Kubnet subnet, in the last session we used the CNI, and today we're going to use this overlay subnet. Okay, so that already exists, so which is 172.16.236. So that subnet already exists. So let's go back into our VS Code to make sure that, all right, so our container registry is created. We'll create this which will create this identity. It is the identity that's assigned to the cluster, to the AKS cluster. And we will save this principal ID and this ID into the variables. So let's do that. So this is the principal ID. I always have an echo statement to just see what the variable is holding the right value. And then we have the identity. Okay. So these are, let me just double check. That we have all of the identities here. And let's go ahead and create the, let's get the VNet ID and the subnet ID here. And then this is a very important step where we assign the network contributor role for that principal ID that we created. And if you don't do this step when you deploy some of the when you deploy the service, it will not be able to talk to the load balancers that are deployed in the VNet. So it's important to have this. And let's just verify this. Okay, great. So now we will create this cluster using the AKS create command. And the two things that are different here is the is a network plugin is still Azure, but network plugin mode is overlay. Okay, so that's different from the ones that we did before. And of course, this is the pod cider, which is different from the node network. This is the subnet ID. And again, it's going to create a 3-node cluster in this resource group. Okay, so biggest distinction here is the network plugin mode is overlay. So let's go ahead and kick off this cluster. Again, I'm using the verbose setting here so we know what's going on. So let's go ahead and kick off this cluster creation. So while that is happening, let's jump back into the draw.io and we'll figure out the different flows and we'll deep dive into the next steps that we will do. All right, so here we are in the draw.io. You can see that we are deploying these 3 nodes. We expect this at the end of the cluster creation. We expect these nodes to get IPs from the node network. And once the nodes are deployed, we will deploy what's called, we'll do a deployment of this pod. And that pod will create 3 replicas, and each of them would be listening on, it's an Nginx demo image, and each of these would be listening on port port 80, right? So let's do a deep dive here to see what that would look like. So let me turn off the inbound, outbound for now. So what we expect is first we will deploy these endpoints, so these pods using a YAML file, and these pods would be listening on port 80. Then we will deploy, create a service. The service is of the type load balancer, so it will create a load balancer. It would create a front end IP, and that would be listening on port 8080. And so let's just fix this over here. So this will be listening on port 8080, which in turn, the backend for this load balancer, and this is where the critical concept of node port that I want to highlight here. We talked about this in the previous videos as well, but node port is a specific port, in this case 31065, TCP 31065, that each of these nodes are listening on, and they are the backend for the load balancer. And then there is a concept of the cluster IP and cluster network, which, as I mentioned before, the idea is that the cluster network is used for the pod to service communication and service to service communication as well. So from that node port, it will get to the cluster IP, and then the cluster IP load balances it to the different pods, right? And this cluster IP is also listening on port. Let's fix that over here, 8080. So then you have 8080 here, to the node port, to the cluster IP, to the endpoints. Okay, so that's how the entire flow works. And I showed you inbound. Inbound comes in to the load balancer, and this is the green flow. And let's look at the outbound. So from the perspective of this pod, it will egress through this load balancer. And we will run the validations over there as well. And let's look at the flow, east-west flow. So the coming from on-prem, we will be deploying another service of the type load balancer, but in this case, it would be an internal load balancer, and I'll show you the YAML as well for that. And the way the traffic will flow is on-prem will hit the internal IP of the load balancer, which will then follow the same path, go to the node port cluster IP to the endpoints. Okay, and then outbound traffic, and this is another concept very similar to Kubnet. The outbound traffic going from the pod to on-prem will get natted to the node IP. So in this case, we have the node IP of 172.16.236. You can see the .4, 5, and 6. So if this pod goes out, it will get seen as the node IP. And that's the critical concept. So if you're setting up a VPN tunnel, you want to use this network in your encryption domain. Okay, so that's the key point over here. Now, one of the questions that comes up often is, and I want to highlight this here, is that outbound. You know, we have other options for outbound. I'll be creating a separate video for that, but you could do outbound using a firewall or a NAT gateway. So just be aware of that. We'll do a deep dive on other outbound options, but the default outbound goes through the public load balancer. Okay, so those are the different flows. Let me just make sure that we've covered all the different points. And yes, so one thing to mention is I've put all of the YAML files here. Just let me see if I can zoom in a little bit. So yeah, so this is the YAML file for the deployment, in external service and internal service. All right, so all of this is in one place in the draw.io diagram. So let's go check if our cluster creation is complete. There we have our cluster is deployed. So let's connect to it. So we'll get the credentials. Then we will see if we can do a get nodes. And there we have the nodes, and the IP is in the 172.16.236 network. And just to kind of make sure you can see this in the diagram, that's our node network here. And then in the portal, that's the 236 is the overlay subnet that we have. Okay, so that's all looking good. We have the nodes. Now let's create a deployment. So what we'll do is we'll create a namespace, and then we'll do a deployment. Let me show you the deployment.yaml file here. So this is of the kind deployment. It's going to create 3 replicas. It's going to use this image, Nginx demos, and expose the pod on port 80. Okay, so that's the deployment. So let's go ahead and kick off the deployment. And then this command is used to validate. Okay, there we have all of our pods running. Here you are seeing the pods running, and you notice that the pods got an IP from 10.2.44.1, 0, and 2. So let's go back and look at this in the diagram. So notice the third octet. I want to highlight something in the diagram. So you'll see that our pod network, our overlay network was 10.2.44/16, and each node gets a different /24. So notice the third octet is 0 for this node, 1 for this, and 2 for this node. And so that way, as you could see, these are the /24s that are carved up for each of the nodes. So now we have the nodes deploy. I'm sorry. Yeah, we have the nodes deployed and we have the pods deployed. So let's go back and deploy a service. The service again is used to expose these pods to the outside world. So first we'll deploy the external service using the external load balancer. And as you see, this is of the type load balancer. We're going to expose this on port 8080 on the load balancer and 80 on the pod. Similarly, this is the internal service. Of course, you have to add this annotation for deploying the internal load balancer. 8080 outside port exposed on the load balancer, and this is on the pod. Very similar to what we did before. So let's go ahead and apply this. And we will see, we can run this command. This watch command helps you watch the traffic. Notice that the external IP is pending there. We have the external IP. So now we should be able to hit it on port 8080 with this external IP. All right, so let's go ahead and deploy the internal, and then we can run the watch command again. And you'll see that it's still spinning up the internal load balancer. This IP is pending. And so while this is getting created, let's go and look at this in the portal. So we'll look at the external service and the external load balancer. So before we do that, let me actually show you, now that we already have the external service, we can take a look at it using this describe command. It's a very useful troubleshooting command as well. So we'll just hit enter, take a closer look at the external service. What you see here is that it has created this external IP um, on port 8080, external IP on port 8080, and also the endpoints. And these are the pods. This is the node port that I mentioned. And also showing you the namespace in which it is deployed. Okay, so there's a lot of troubleshooting points over here. If the endpoints are not showing up, you can ensure that you can double check your configuration. So this is very useful. So let's see if our internal service is defined. Okay, there we have our internal load balancer and our external load balancer deployed, and the services are answering. So let's go back in the portal and validate this. So we'll first look at the Kubernetes cluster. We'll refresh this. As you can see, this is our overlay cluster. And if we go in the resource group, you'll notice that it has the identity and the ACR and other resources that we created, but it doesn't have the two load balancers that we created. So the way to see those load balancer is that when you deploy AKS cluster, a special resource group MC underscore gets created. And if you look at that one, you'll see the two load balancer. This is the external load balancer, and this is the internal one. Okay, so now let's go look at the external. Again, this is very similar to what we did with Kubnet and CNI. So I'll do a quick overview. You can see the two IPs, the backend pool, and these backend pools are 4, 5, and 6. These are the node IPs, always the node IP, and then you'll see the node port over here, 31227. That's the internal load balance. I'm sorry, that's the external load balancer. Let's look at the resource group again, and we'll look at the internal load balancer. Same way, it has the private IP. It got put on the node network. Then backend pools, same thing. It's talking to the nodes, and we'll take a quick look at the node port here, and it's using the Kubernetes backend pool. Okay, so one distinction between the external and internal load balancer, the external load balancer also has the outbound rule. So remember the flow we showed you about outbound, it egresses using this 30.141 IP. All right, so let's go jump back in here one more time. We'll take a quick look at we looked at the external service. We'll take a quick look at the internal service here. And there we can see the internal load balancer IP and the port, the external port, the target port, and the endpoints. Okay. So these are the validations that we did from a service perspective. Now let's do some more validation for inbound and outbound traffic, right? So what we will do is we will exec into one of the pods, and then we'll verify inbound and we'll verify outbound traffic. So let me clear this. Let's get a pod name. We can pick any pod. And again, in this output, these are the nodes. These are the pods. As you can see, it starts with the pods, and pods are in the 10.2.44 network. So let's exec into the pod. And we'll use this pod. You can pick any pod. And then we'll say dash n, important to use the namespace, and then we will do sh. So if I look at the IP address, it's in the 10.44.178, which you can see it here as well. And then if I learn the curl ifconfig.io command, you can see that we are egressing using this IP, the 30.141, which was also the IP on the load balancer here, the outbound IP. Okay, so that's outbound traffic, and then inbound, we can just run a curl command against this public IP and port 8080. So we'll just run this command and I'll just do a grep on address because I have a container running that echoes the address of the pod that it gets connected to. So as you can see, it got connected to the pod 0.134. And if you want to see how this looks in the browser, we could do that as well. So let's just do a quick test here, and you can see that it connected to, in this case, 2.243 pod. Okay, so and that pod, if you kind of jumping back into the diagram, what we just simulated was this green flow going all the way to the pod. Okay, so that's some of the validations that we ran. Now let's take a look at real quick at some other troubleshooting tricks. So this was inbound and outbound. And you could run this command called kget events in the namespace. This is a very useful command. If there is a problem, you can see some things in the in the output. You can also do you can also do run logs against uh, a particular pod. So let's do that. First, let's get some pod list of the pods, and then we'll run this klogs command against this pod. So let's do klogs. Let's pick one pod here. And we'll do, we have to specify -n demo -ns. And if for whatever reason the container is not running, you can see the logs on the container. Very useful command. And we did the describe command before, and we did the get services command before. Describe is also very useful. One of the things that from a network perspective that I have seen happens is that issue I mentioned with the network contributor role. So if that is the case, you'll see in one of the logs showing this message where the cluster cannot talk to the network resource. And so make sure that the identity is set up correctly. You can see the identity using this command. So these are some quick tips for troubleshooting. And lastly, if you want to see the DNS IP, you can look at it using this command. And this is the DNS cluster IP that the pods use for DNS resolution. It's used by core DNS, and if you remember, that was the IP that we specified over here in this CIDR. So few important distinctions that I want to make from the perspective of the three CNIs that we have learned so far is, if you think about it, this one looks very similar to Kubnet, but it does not have that UDR, the route table that was needed to route traffic between the nodes. There was a UDR that I showed you earlier that was set up at the subnet level, and with overlay networking, we don't need that. Now, there's a small tip that I want to show you. I recently had a customer asking for this. So let me just incorporate that here just so you have an idea. But let's zoom in a little bit on this east-west flow. Remember I mentioned that when you egress from here, you would not see the 10 to 44 IP, but you would instead get seen as the node IP. Now, how do we validate that, right? So I did a quick test, and I'll show you how to validate that. So I am on this, I'm on this VM where I'll fire up little web server, and so you can see that So we'll just fire up a web server here. And oops, sorry, I am in my, let me just log in to this VM here. So we'll log into this VM. And if you look at this VM, it's on a different subnet than where the AKS cluster is, and you could do the same test for your on-prem traffic as well. But just to do a quick test, what I did was I ran this, a web server, and what we will do is we will hit it from one of the pods that we have here. So we will exec into the pod like we did before, and then we will, as you can see, we will curl to this on 8080. And we got this East VM, and instead of getting the IP, this IP, we will see a different IP. So let's go and validate that. So it showed that it came from 236.5 and not from the pod IP. And why is that? And that proves that when the pod goes out, it gets seen as the node's IP. So going back to the drawing board, the node's IP is .5. So it's not the 10.244 IP, but it's the 10.16.236. All right. So that was the test, a quick test that I did, and it's going to be the same thing for on-prem traffic. I was on this VM, which is on a different subnet when I ran this test. So that ends this presentation. Thank you again for joining me. I hope you enjoyed this session. Drop me a comment. Let me know what kind of network model you use in your environment, and or if you would like to see any other networking topics, let me know. Thanks and have a great day.